Hello everybody, our lesson now is about forces and motion. What is force? Force is a push or pull exerted by one object on another. It has direction as well as magnitude, so it is a vector. The SI unit of force is Newton, which is represented by letter N. Small forces can be measured using a spring balance. The greater the force, the more the spring is stretched, and the higher the reading on the scale. Many fairground rides involve sudden changes in speed. The picture shows the roller coaster. What are the forces at work in a roller coaster? If you are falling downwards, it is the gravity that affects you. This gives you an acceleration of about 10 meters per second square. When the brakes slam on, the gravitational force may be greater. The brakes make use of the force of friction. Changing direction also requires a force. So when you loop the loop or veer to the side, there must be a force acting. This is simply the force of the track whose curved shape pushes you around. Roller coaster designers have learned how to surprise you with sudden twists and turns. You can be scared or exhilarated. However you feel, you can release the tension by screaming. The picture shows the space shuttle accelerating away from its launch pad. It takes an enormous force to lift the giant space shuttle off its launch pad and to propel it into space. The booster rockets that supply the initial thrust provides a force of several million newtons. As the spacecraft accelerates upwards, the crew experience the sensation of being pressed firmly back into their seats. That is how they know that their craft is accelerating. Forces change motion. At one moment, you will see that the airplane is sitting on the ground stationary. The next moment, it is accelerating upward, pushed by the force. The following are some common forces. The first one is the weight. The weight of an object is the pull of gravity on it. Weight always acts vertically downwards. When two objects touch, there is a contact force. It is the contact force that stops object falling through the floor. So again, what is a contact force? It is a force that is exerted only when two objects are touching. The next is friction. You will see in the illustration that there are two forces, the pushing force and the friction. The pushing force determines the direction of the motion. Now, what is friction? Friction opposes the motion. It acts in opposite direction. The next common force is air resistance. Air resistance is also known as drag. Air resistance or drag is the force of friction when an object moves through air or water. Another common force is upthrust. You will see in the illustration that the boat has gravity pulling it down and the upthrust of the water pushing up. Because the forces are balanced, the ship floats. So what is an upthrust? It is the upward push of a liquid or gas on an object. The upthrust of water makes a person float in the swimming pool. Forces produce acceleration. In this illustration, the car driver is waiting for the traffic lights to change. When they go green, he moves forward. The force provided by the engine causes the car to accelerate. In a few seconds, the car is moving quickly along the road. In this illustration, the arrow in the diagram shows the force pushing the car forward. In illustration A, if the driver wants to get away from the lights more quickly, he can press harder on the accelerator. The forward force is then bigger and the car's acceleration will be greater. In illustration B, the driver reaches another junction where he must stop. He applies the brakes. This provides another force to slow down the car. The car is moving forward, but the force needed to make it decelerate is directed backwards. If the driver wants to stop in a hurry, a bigger force is needed. He must press hard on the brake pedal and the car's deceleration will be greater. In illustration C, finally, the driver wants to turn to a corner. He turns the steering wheel. This produces a sideways force on the car, so that the car changes direction. To summarize several things about forces, first, they can be represented by arrows. A force's direction shown by the direction of the arrowhead. Second, a force can make an object change speed. A forward force makes it speed up or accelerate, while a backward force makes it slow down or decelerate. Third, a force can change the direction in which an object is moving. The illustration shows that there are two or more forces present in a particular instance. First, the engine is providing a force to accelerate it forwards. Second, there is another force acting which tends to slow down the car. This is air resistance, a form of friction caused when an object moves through the air. This force is also called drag, especially for motion through fluids other than the air. Motion can be best described by Newton's laws of motion. Let us first discuss the Newton's first law of motion. This is also known as the law of inertia. Now, what does the law of inertia say? An object at rest will remain at rest unless acted on by an unbalanced force. An object in motion will continue with constant speed and direction unless acted on by an unbalanced force. So take note that the unbalanced force can make an object at rest to remain at rest, and an object in motion can be stopped by this. Objects with greater mass have more inertia. It takes more force to change their motion. Let us proceed our discussion with terminal velocity. Consider a skydiver. At the start of his jump, the air resistance is 0, so he accelerates downwards. As his speed increases, his air resistance also increases. Eventually, the air resistance will make big enough to equal the skydiver's weight. At this point, the forces are balanced, so his speed becomes constant, and this is what we call terminal velocity. What are the other words for terminal velocity? We can use the words escape velocity, flash, greased lightning, lightning speed, speed, velocity as other words which refer to terminal velocity. So what is terminal velocity? Terminal velocity is the fastest speed an object can obtain while moving through a fluid that has resistance dependent upon the velocity of the object. Terminal velocity occurs when acceleration reaches zero. Take note that net force is equal to zero. Therefore, the forward force is equal to the resistance force. When an object falls through the air, it picks up speed and the air pushes back even harder, driving the acceleration down. Remember, the acceleration decreases, but it is still accelerating. Hence, the velocity increases all the way to terminal velocity. In general, air resistance depends on the shape of the falling object and the speed of the object. Also the density of the fluid, but that is typically constant. The graph shows how an object's velocity changes as it moves through a fluid. Remember, the fluid can be a gas or a liquid. The graph shows the object must be experiencing a resultant force at the start, like gravity or thrust from an engine. This force is eventually balanced by the force of friction or drag from point T onwards. The maximum or terminal velocity of the object is achieved at point T. That's all, and I hope that you learned something about forces and motion through this video. This is Teacher Rose reminding you to keep safe and guard your health always. Bye.